Okay, so we've viewed a couple of examples of physical changes and chemical changes, and of course, as we briefly said, any properties that are associated with those changes are termed physical properties associated with physical changes, and chemical properties are associated with those that are chemical changes. So anything that doesn't alter the atomic arrangement but is a change, of course, properties associated with that will be physical properties. So all of the examples that we gave discussing phase changes would be physical properties. So what do we mean by properties? Well, of course, going from a liquid to a gas occurs at a specific temperature at atmospheric pressure, and that is termed the boiling point. So boiling point is an example of a physical property. And any of those points associated with physical changes, such as the melting point, the other analog, the freezing point, would be physical properties. Usually anything that we can observe with our physical senses, of course, do not alter the atomic arrangement. So things like color or odor. We can see that water is colorless, doesn't have a distinct odor, and none of those observations would rearrange hydrogen and oxygen. Gasoline certainly has an odor, but it still doesn't rearrange the atoms within the molecules inside of a gasoline sample, and so those would be termed physical properties. Another very simple physical property would be shape. You can tear a piece of paper in half or bend a piece of metal into a certain shape, draw it into a wire. You're changing the physical appearance of that material, but you're not doing a chemical change, so of course that is a physical property. All the chemical properties associated with chemical changes can be deemed as a very simple term, and that of course is reactivity. As we will see that in order to rearrange atoms, we're going to have to perform a chemical reaction. So whether or not a substance reacts with other things, we deem that it's reactivity, and that of course is the overall scheme of a chemical property. We can talk about specific reactions, and those properties would be associated with chemical properties. Whether or not something burns in the presence of oxygen, we term that flammability. That is an example of a chemical property. Okay, whether or not something is acidic or basic is another chemical property. Acidic or basic, meaning that it's an acid or a base. Whether or not something is toxic, toxicity is another very applicable chemical property. All of those are going to involve chemical reactions, and so therefore change the atomic arrangement, and of course our chemical properties. We can discuss any of those properties, chemical or physical properties, in terms of how they are dependent on our sample. We can talk about extensive properties and intensive properties, and there's a very big distinction between these two. Extensive properties depend on the amount of material you have, or the quantity of matter. If you add more matter, does that property change? Of course, if it does, that's an example of an extensive property, and that is two examples here would be mass and volume. If you add more atoms to a sample, its mass will increase. It will also take up more space, and so therefore mass and volume are excellent examples of extensive properties. Again, dependent on how much matter is present. On the other side, there are intensive properties, and these are properties that are independent about how much matter you have. Okay, and these are termed intensive properties. And the way I remember that is, of course, intensive starts with an IN, and so they are independent of the quantity of matter. Intensive properties are independent of the amount of material. An example of that would be boiling point or freezing point. Okay, if you have a small beaker of water, let's say 20 milliliters of water, okay, it will freeze at 0 degrees Celsius. If you have a huge lake in northern United States or Canada, that water, if it was pure water, would freeze at 0 degrees Celsius. So it doesn't matter how much you have, a little bit of water, a lot of water, they are going to both freeze at 0 degrees Celsius. So it's independent on how much matter you have. Okay. One of the aspects about intensive properties is they can be used to identify matter. Okay, extensive properties cannot. If you have an example, if you have a sample of a colorless liquid, okay, one of the things you can do is determine the boiling point of that liquid. Okay, ethanol has a boiling point around 78 degrees Celsius. Water has a boiling point of 100 degrees Celsius. Okay, so if you measure the boiling point of this unknown sample, and it's around 78 degrees Celsius, you have a really good proof that it's not water, and some evidence that it is ethanol. Of course, you'd maybe want to do more tests to make sure it's ethanol, but they certainly can be used to identify the material. Extensive properties cannot. If you have 10 milliliters of that colorless liquid, that gives you virtually no indication about what property or what the identity of that material is, based just on the fact that it's 10 milliliters.